Okay, let's dive right into this explainer and tackle a kitchen myth literally almost everyone believes. If you've got a kitchen, you've almost certainly got a microwave sitting right there on the counter. We use them every single day, right? We just press a few buttons and blindly trust this magic box to hand us a hot meal in 2 minutes. But the way you visually picture what's happening inside that box, it's probably completely backwards.
You've definitely heard someone say, or maybe you've even said it yourself, that a microwave works by heating your food from the inside out. And honestly, visually, logically, it makes total sense. Sometimes you pull a bowl of leftovers out, you touch the outside of a piece of chicken and it's barely lukewarm, but then you take a bite of the center and it absolutely incinerates your tongue. So we assume, okay, it must be projecting heat deep into the core and working its way out.
Well, wrong. Absolutely 100% wrong. Stop thinking that right now. We are going to completely shatter that idea and fundamentally rebuild your understanding of what's actually happening on your kitchen counter. We gotta clear out the bad intel so we can replace it with the incredibly cool reality of how this appliance really functions.
Section 1. Meet the magnetron. To really grasp what's happening, we have to peek inside the hardware. So, unlike a normal, traditional oven, there's no open flame or hot air circulating in there. When you bake something, you're just sort of bathing it in a hot environment. But a microwave takes a totally different approach. Hidden behind the casing is this highly specific component called the magnetron. And its entire job, literally its sole purpose in life, is to act as this wildly powerful engine that pumps out invisible electromagnetic waves into the cooking chamber.
And what's really fascinating here is the specific frequency it uses. These waves are blasted out at exactly 2.45 gigahertz. Now, that's not just some random number engineers pulled out of a hat. It's a highly calibrated frequency designed to do one very specific thing to the molecules sitting right there on your plate.
Section 2. The physics of friction.
So what exactly are those 2.45 gigahertz waves hunting for inside your leftovers? Because they aren't just broadly heating up the air or your ceramic bowl, they're targeting water. See, water molecules are polar, which basically means they act exactly like tiny microscopic magnets with a positive end and a negative end. And virtually everything you eat that has any moisture in it is completely packed with these little microscopic magnets, just waiting to interact with an energy source. When that microwave radiation washes over the water inside your food, it creates an intensely oscillating electric field. Suddenly, all those positive and negative ends are caught in this violent magnetic tug-of-war. The field literally forces the molecules to flip and rotate back and forth, trying to align with the shifting waves. And it does this, get this, billions of times per second. And listen, if you're trying to visualize this, do not picture it happening smoothly. Forget about some gentle waltz of warming molecules. At the microscopic level, it is absolute explosive chaos. It happens violently. We're talking billions of water molecules whipping back and forth at incomprehensible speeds, just smashing into each other. And you know when you rub your hands together really fast on a cold winter day to warm them up? It's exactly like that. This extreme, chaotic movement causes intense friction at the molecular level. So to clearly break down the mechanism here, step 1, the waves force the water inside your food to rotate insanely fast. Step 2, that crazy fast rotation causes intense molecular friction. And step 3, that friction bursts into the heat that actually cooks your meal. The craziest part is the heat doesn't even come from the microwave itself. The microwave just provides the energy that forces your food to literally heat itself up through physical friction. Like the quote says, there's no magic, no mystery, just physics. Once you can visualize this intense microscopic friction, the whole appliance suddenly starts to make a lot more sense, right? Section 3. Why microwaves heat unevenly. Now, let's use this brutal physics to answer a huge question. Why is your microwave experience often so frustratingly inconsistent? You know the feeling. You bite into a frozen burrito and the edges are practically boiling lava, but the dead center is a literal icicle. Here's why. The microwaves generated by that magnetron, they actually only penetrate a few centimeters into the outer layer of your food. They dump all their energy into the water molecules right there at the surface. That means the deep center of your meal doesn't get hit by the waves at all. The heat has to spread inward purely by normal conduction, just heat naturally bleeding from a hot area to a cold area. That perfectly explains those freezing cold spots and lava-hot zones. And hey, it's exactly why the instructions always beg you to pause and stir your food halfway through. This visual of water interacting with waves also dictates how different ingredients behave. Foods packed with water interact incredibly well with the waves because, well, there are millions of those polar molecules ready to rotate. But dry foods, they heat up very poorly. Less water means less interaction with the waves, which means way less friction and ultimately way less heat.
And this right here is exactly why bread is the ultimate microwave victim, because bread lacks that dense water interaction. Trying to microwave it just doesn't cook it properly. The tiny bit of moisture it does have quickly turns to steam and escapes, leaving the starches to totally seize up. You aren't gently warming your roll, you're physically mutating its structure into an unchewable, rubbery monster.
Section 4. Busting lingering myths. Before we wrap up this explainer, we need to violently destroy one last piece of pure nonsense. We've tackled the whole inside-out myth, but there's an even more persistent rumor about microwaves that just refuses to die, and we need to clear it up for good. Please stop believing the idea that your microwave is somehow turning your food radioactive. Seriously, no way. Because the word radiation is used, specifically electromagnetic radiation, people immediately confuse it with nuclear radiation, like X-rays or gamma rays, the stuff that can actually be dangerous. But there is a massive difference here. The energy involved in a 2.45 gigahertz microwave is incredibly weak on the electromagnetic spectrum. It has absolutely zero power to alter atomic nuclei or mess with your DNA, none. As we've explored today, literally all it can do is excite molecular motion to create friction. That is the absolute ceiling of its capability, making water jiggle really, really fast. So here's what I want to leave you with today. The next time you hit start, watch that little turntable spin and hear your food popping, I want you to remember the brutal physics at play. Visualize those tiny polar water molecules violently smashing into each other billions of times a second. Knowing what you know now about conduction and wave penetration, how are you going to look at your next plate of leftovers? Keep that image of intense molecular friction in your head, and maybe, just maybe, you'll actually remember to stir your food this time.